Hi, I'm Shiv.
And I'm Chitra.
We are the co hosts of this show, Software People Stories.
We're happy to bring you stories of people associated with software as makers or consumers.
In every episode, we talk to people on their own personal and professional journeys.
Their interests and approach to work and life in a free flowing conversational format. We hope that you will be able to draw your inspiration from their experiences and insights.
These podcasts are made possible by PM Power Consulting, who have helped individuals, teams, and organizations on their delivery excellence journeys. Hi, welcome to this episode of the Software People Stories. My guest today is Paul Arieckal. Paul has been in the IT industry for 29 years and is currently the Vice President of Engineering at Global Automation India Private Limited. In today's conversation, Paul talks about how he learned the rigor of software development as computing resources were scarce when he started programming, how considering constraints at the time of design helps in creating single user or multi user capable software, and how the passion for writing software shows as rigor when writing code. And sometimes when assumptions that are made while designing go wrong, with the help of a story of a time tracking application that he and his team built. He also enjoys debugging, and in the age of cloud and microservices, how top down design is still relevant, and by sticking to the basics, how they were able to bring down the footprint of an application from approximately 2 GB to less than 200 MB. How his passion for gardening helps him draw inspiration in creating good software, and how learning violin taught him about writing software. And of course, the importance of a test first approach, whether it is in gardening or coding. If you want to know what Paul compares debugging to get a high, listen very carefully. He also talks about how one can avoid a burnout in the supposedly stressful field of software and the importance of staying focused on the core of the problem we are solving and not get lost on the frills. Listen on. Hi, Paul. Welcome to the episode of Software People Stories, because that's a new branding we have given for what used to be software lifecycle stories. So it is all about people who've been in software, who've created software or consumed software. And also, it's an opportunity for us to catch up after a long time. We normally start with the guest introducing oneself. So if you can introduce how you got into software and then what you do otherwise, what your other interests are, we can take it from there.
Okay, hi Shiv. My name is Paul Arieckal, and I've been with the software industry for over 29 years. I started off as an electrical engineer, but even at the graduate studies, I was more interested in computers, programming computers. So most of my projects that I did in electrical engineering were also computer simulation of power systems, distribution networks, cabling, and things like that. And after 1 year of working in that space, I found that engineering software did not interest me, and I moved to other commercial software application industry. I've been working in this space for now, in particularly in the commercial software for over 25 years. My interest in software started during my undergrad days, and that's when the first mini computer from Pro landed up at our institute. And we started writing programs in Fortran at that time. That was the only language available for writing engineering software.
With all those, but 8.5-inch floppies
Yeah, yeah. I don't know. Yeah,
are huge.
huge. Yeah, and more often than not, the computer would crash, and we would have to reboot the system and get it working. I don't even recollect how much memory was there, but I think it would be in KBs. Um, and then from there, I moved on to bigger machines during my postgraduate studies at ISC. So I think we were working on a wax. Again, there too, it was Fortran. First time that I had the exposure of using terminals to write software, and you had to submit your program in advance because you don't get computer time, come back the next day to collect the output and analyze it. So I think that started, that created a rigor of software development in me, where nowadays you have the luxury of writing a line of code, submitting it for compile, watch, and getting the response immediately to know how it works. But those days you had to work, you had to wait for a day before you get the response. And so that required you to be very careful in writing the program, ensuring that there are no compiler errors, because it will take a day to for you to understand that there was a compiler error. So you would lose a day. So that was the progression of in the software development that I had, and and now it's more to do with uh, the newer tools, Java and enterprise Java, things like that. It's a it's a big shift from the Fortran and C programming days.
Yeah, interesting. So from engineering software to software engineering.
Yeah.
Yeah. And I remember my first program was also in Fortran at IC. So how do you find the shift from even in commercial software working on, let's say, PCs, more of a single user kind of applications to working on enterprise class applications?
Yeah, the requirements when we are working on the standalone PC systems writing software for that environment, uh, we did not have to look at multi-user capability and sharing the processor load and things like that. You're pretty much you had the processor and the memory all to yourself to write. I remember, in fact, one of the first pieces of software that I wrote in the commercial software space was with you, Shiv. It was called disk to tape utility.
Yeah,
It was to copy
D2.
the image of a disk into a tape,
Mhm.
and it was written on a PC. So you had on a Windows PC, and you had all of the PC memory available to allocate to yourself and write code. But now it's not. Now it's actually you have to be careful about that. But the system takes care of ensuring that the space you don't overwrite your space into somebody else's memory space. Uh, but still, having said that, we still have to be aware of the multi-user load and the processor loads and write uh, more optimized pieces of software. In fact, I think the need to write optimized software is even more now than it was when during the Windows standalone PC days. Uh, because often I find many of us simply assume that you will have all of the server processor to yourself, you will have all of the server memory to yourself, and you can allocate and more than what you want and keep using it. But I think that's not, we have to be careful that we do it even as we develop it and design the software, because putting that constraint, working around that constraint after you develop the software is not very easy. You have to rework some of your designs. So it'll be good to have the constraints, software written with the constraints even at the time of design itself, and not to wait for the end after you develop the software to put in the constraints and change the design.
See, my very rough analogy for this has been either keyboard programming or mouse programming. And when you do keyboard programming, you get deep into code, get into debug, try to understand mouse programming, probably drag, drop, click, set a few properties, it all kind of works. But you also mentioned that the Fortran programming time gave you the discipline of making sure that your logic is right and everything else before you ran, and now you have the IDEs. Do you see a change over time, not only with technology, in terms of how people who get into software development approach solving the problem?
Yeah, like I said, I think the fact that there is less of a rigor in designing and ensuring that there are no errors in design and code, that actually goes spreads to other areas of software, life cycle development. For example, even in when you're doing the spec at the spec stage, people do not. I feel that those who do not have a rigor in doing a detailed design and code do not have a rigor in detailing of the specs also. Most of the time, it's like everybody works on like a hobby project. You write your own spec, what you think is sufficient, and you start writing code. Then you show it to somebody, and then they'll say, no, 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 this doesn't work. You have to change your spec. You go back, change the spec. So I feel that some of the tools and methodologies actually incentivize you to sometimes to misuse those tools and technologies to not adopt a rigor in software. Whereas the older generation, like mine, I think they are more careful, they are more detailed in their analysis even before writing the first line of code.
Yeah, I remember. Was it the point of sale product that you worked on when you said, I want to go offsite? For doing the initial brainstorming and then trying to come up with the conceptualization of the product.
Yeah.
Today, people talk about product management and understanding the users and then trying to do all that. It's coming in, but I guess the discipline that you've been trying to follow has been there. Now, the question is, we had one guest, in fact, yeah, you know him, Dorai, as a podcast guest earlier, who was talking a lot about how do you train people. It's not about learn and do, but then do and learn. So, what approaches have you found effective when you're inducting new members in the team, particularly those who don't have a commercial or an enterprise programming background?
Um, we have not had the luxury of, to find out, to analyze what would work and what not in terms of inducting new members. But I have noticed that somebody who has a lot of passion in writing software tends to have more rigor in writing software. Whereas somebody who has taken up software as just a career, not having as much passion as they would need to write software, tend to be less rigorous in their software development. I don't know if that's if I should be generalizing it that way, but that's my experience. Um, I've had colleagues who have who are extremely detailed in their analysis and rigor of software development, and those who are uh, like cowboy programmers
Mhm.
start writing. Even actually in the earlier days, there were cowboy programmers, but they were cowboy programmers with an with a with an objective in mind. They had very clear objective of what they had to do, and
Okay.
they would have done some analysis or lot of analysis, but not captured it in a note or document or anything. But they had it very clearly laid out. They would have the high level objective identified.
Mhm.
Today, I think sometimes what happens is that we work with some low level objective before even realizing what the high level objective is. And I think that results in all this, rework and redoing and going back to start to the spec stage and then going to code again. I think it's the big picture approach is not there.
But in enterprise software, to get the big picture, you also need to either ask the right questions or discover the requirements with customers. So, have you had any, let's say, funny experiences in terms of getting some specs, thinking this is what probably they need, and after it is done, find that, well, oops, it's probably not something.
Um, I haven't had much of an experience that way. Um, but yeah, recently we did the time recording system, and we built the time recording system based on our understanding of the normal, operations in an organization. So we organize the software components into the same way as a normal software development happen. So we would have like an organization, then you would have a project, and then under that you would have milestone, and the milestone would have tasks. And so we developed the whole thing, and we published it. And then we found that the first user who came up said that, no, I don't want to create an organization and and a project and milestone and task. I just want to have tasks.
Okay.
So and we were completely thrown off because and then we tried to hit that requirement into the hierarchical structure that we had, and that failed miserably actually. And so finally we got down to redoing this whole thing.
Okay.
So now we support the hierarchical structure as well as a very flat structure which has no structure.
Yeah, interesting. Because when you spoke earlier about being mindful of the resources consumed, whether it is memory or don't assume that everything is available only for your program, with the move to the cloud, and one is, let's say, microservices are writing small functionality, and the other is about stitching multiple of those services together. Probably third party services, like whether it is maps or anything, and you don't even know how it is going to evolve or what it's going to consume. Uh, in terms of design, do you think today it is better to do a bottom up design rather than spending a lot of time in creating an architecture and trying to design?
I still think that creating an architecture and then to design is the best way to go, because even in the cloud, while there may be computing resources available to you at your disposal, there is a commercial aspect that we have to consider. I mean, if you have like a single processor, 1 GB memory configuration with some 10 GB hard storage space, it'll cost you something. But that doesn't mean that you should use all of that resource that is available, because you can also get a 8 processor, 20 GB memory and 200 GB storage. But that's going to cost you more. So just because that it's available doesn't mean that you can use it, because there is a commercial aspect that you have to consider. After all, we are here to make money. So yeah, selling some orders. So you have to be very careful about. You know, so, yeah, so that the requirement to ensure that you have a solution that uses the least configuration available today is still there. In fact, I have an experience recently. We developed a storage data migration piece of software, and we just used Java and we just took this standard Java runtime and built this whole thing, and we demoed to the customer, and we found that the memory footprint for us for our software at that time was about 2 GB. And the customer said that, we only have 200 MB available for the software. So finally, we had to get down to start trimming out and removing all of the unnecessary packages we were using. And we found that we actually came down to 180 MB. So, so there was room to do that, but we never thought of it. We just assumed that, all of the memory that we want is be available to us. So this is what I said. Early on, if we had known what the constraints were, we could have done it. I'm sure we would have done it. But doing it without knowing what the constraint is and keeping your requirement to the minimum would be the best solution that you can offer to your customer. Rather than wait for the customer to tell you that this wouldn't work and then you go back and rework it. Because we spent almost 2 months to get this memory footprint down. Trimming out a lot of things. In fact, we even redesigned some parts of the software.
Yeah, that's a very, very insightful story. Do you have any stories on the user experience or the user interface side, something similar?
No, actually, we've been always been extremely careful about user interface. So we spend a lot of time trying to, beating the user interface up and ensuring that it would be the best that we can offer to the end user. But yeah, there was some tools that we built and there was a user interface which we thought was very highly intuitive, and we found that the users were actually confused with the whole user interface, and we had to change it. But that was an internal tool. So I mean, if you can find so much, so less acceptance to a user interface within the organization, I could imagine how difficult it would be to help to provide a user interface that will work well outside the organization.
Going off a little bit, I know that you have a lot of other interests than coding, in music or gardening, etc. Do you find any analogies from those disciplines that can be used in software development?
Yeah, actually, it's more like cross training for me. I find that, especially in gardening, I find that, so I do a lot of, gardening. I try to put in technology to conserve water, to use the best soil nutrition and things like that, to maintain humidity. So try to use technology, and most of it is there are no standard solutions available for a small garden. There are solutions available for large farms, so it's a exercise in adapting some of those concepts and tools that are available there into a small garden. And again, money is limited because it's a hobby. I don't want to spend a lot of money on this. So I have to get the best equipment for the least cost. And so that requires a lot of analysis and figuring out vendors who would provide it and understanding some of those. For example, I use a drip irrigation system. The first time I just went and bought a few drippers. I had to buy 100 drippers because they come in 100 dripper packets. So I got the dripper and I found that that's like a 8 liter per hour dripper. So which means there's so much water that comes in. And then I found that there are actually 2 liters per hour drippers, there are 4 liters per hour drippers. So you need to select some of these. And then I arrange the pots and I fit the drippers And I found that there are some plants in the pots in that line that require less water, and the others require more water.
Okay.
So you can't use the same dripper for all of them. So these are, it told me that I need to do much more analysis and explore things that you do not know. You have to actually figure this out before you start putting money and putting on drippers. So now I have packets of drippers lying at home of no use, and I'm trying to find somebody who will just take it and say, go ahead and please use it.
Or maybe you should just invest in a big farm.
Big farm, yeah. So I'm saying, so I think that need to do more analysis um, stood me in good stead in software development. And the other thing from music is I find that is that I've read a lot about I read a lot about music. I read a lot about playing the violin and all that. But I found that when I started playing the violin, all that knowledge was all not not even applicable, because finally you have to play the violin, right? So that's even that is something that I take in software development. It's not sufficient to read about designs and architecture and all that. You have to sit and do a design and architecture before you can even understand what really is. So there's a lot of cross training in those through those hobbies that I can bring to software.
Okay. See, one question triggered by this is when you pay attention to detail. Now, how do you get into a discipline of validating it or testing it?
Yeah, actually, that's the first thing that I've learned that we should do. That is, even before you start doing something, you have to first test it. So going back to gardening, when I finally figured out that the 2 liter per hour, drippers are available, I then built one sample line, and then I measured and ensured that there is really only 2 liters per hour coming from the drippers. Because the timers are set for 1 minute and 2 minutes and 3 minutes.
Okay.
So I need to be very sure how much of water I will get. So even though the spec said 2 liters per hour, I did a test to ensure that there is 2 liters per hour. And that's the same thing I do even in software development. So even in the new storage migration service product that we're developing, we first build elaborate test frameworks to ensure that we can test every component in this whole solution. And we use the test framework and the test cases as the specifications for developing the product, actually.
Okay.
For writing code. So that's the first thing that we're doing. And I think I believe that through my other projects that I've done, this one is the one that is best done. Because I think because we did the testing part first, set up the test frameworks first, did some tests, and then test the test framework, and then start writing the code.
What has been the most challenging bug that you had to fix? And after you fix it, oh, how did we miss this?
Yeah, I think it was during the time that we're developing the point of sale system. We used to, I mean, there were bugs where it used to just simply crash the system, and this was written in C++. And after a few such instances, I found that it was all due to memory allocation problems. I mean, allocating memory, but misusing that memory allocation, right? Writing more than what you have allocated. And I found that later on, a complete crash, is the easiest to debug because you know exactly that there is a memory allocation. Whereas if it's a functional bug, I found it extremely difficult to debug because you have to understand the functionality. I can't pinpoint a particular bug that was the most challenging, but for me, I think functional bugs are difficult to debug than a crash. A crash, the moment somebody reports a crash, I know for sure that we have to look at array allocation, memory allocation, overwriting a memory, overwriting an array. Even now, when I do Arduino programming, that's the first thing I look at. When the system stops working, hangs, I know that I have overwritten an array or something.
So how do you find the switch between working with all these IDE tools and all that in your work situation, and then when you go to Arduino, it's probably trying to actually look at bits flowing.
Yeah, I think even at an IDE level, in order to understand the a bug if it occurs in a code, you have to know bit level, you have to have bit level knowledge. Otherwise, I think it's very difficult. If you don't have that skill and expertise, I think it's very difficult to debug the problem. Simple problems are easy to debug. I mean, you don't need that knowledge. But then there are these real, I remember there was a case of the a web server hanging in one case, and we were wondering why. They were looking at the most common place to look at is to see if the code is functioning the right way, the wrong way. There's a functional code working correctly. But finally, we found that actually the problem was not there anywhere. It was actually in the fact that we were opening database connections and not closing it, explicitly closing it. So that was, and it used to manifest in different places, in different ways. So each one we were looking at in isolation, but we found finally when we analyzed, we found that we were just not closing all the database connections. So if you don't know, if you don't have a knowledge of the detail of how the driver works, then I think it's very difficult to debug. It's because I had that skill. I looked at that specific area and said, can you just see if we have over-allocate some resources? The database connection was one of them.
So do you find debugging as an activity enjoyable as a challenge or stressful?
For me, debugging is an enjoyable activity actually. In fact, I relish bugs appearing and going to debug it. Because I think it sets off some, it's like taking a swig of liquor and you get a high on it. It's very similar to that actually.
So how do you get that kind of an attitude or approach in somebody who's starting out their career?
I'm a bad teacher, but so I don't know how to. I always hope that people would, look at me as an example and then try to inculcate that same approach to anything that they do. Yeah, no matter how much you talk about being detailed in analysis and adapting a rigor and all that, I think you have to do it. It has to come from within you to do it. So I don't know how I can get somebody else to do it.
Yeah, the idea of these conversations is to get some insights into how you do it so that they can probably pick up ideas and maybe get inspired, maybe try out things on their own. Are there any other tips for creating software faster?
I think
more. This question is triggered by I interact with a lot of these aspiring entrepreneurs. At least in Bangalore, everyone thinks that if they write an app, they are an entrepreneur. But then they go cook up something and think that they have a solution. So I'm not talking about those kinds of half-baked things, but then if you want to do something but small, not necessarily solve large problems, a lot of small problems, how can we reduce the fear of creating something and do something quick, which can be shown to users or people can actually use?
Actually, I think if somebody is developing a solution, they have to have a clear focus on or an idea of what the actual problem is. Okay. Not what the perceived problem that they perceive it as a problem. What is the actual problem? Yeah. And only develop a solution that will exactly focus on that problem and solve the problem. Normally, I find that many of us tend to tend to digress. So we start looking at the frills to a solution than the core solution itself.
Okay.
And the frills become the core for us, but
Mhm.
that really doesn't matter for the final end user or customer.
Mm.
So, and that's where I think many times some of the apps are just written and nobody uses it, or solutions are written.
Mm.
And I've had a few such experiences myself,
Mhm.
and not having focused on the frills rather than the core of the core problem itself.
Mm. So, how do you find this balance between work and non-work or life? That's one thing that everyone seems to feel that software as a career, could lead to burnouts.
I think the choice is yours. So once I finish work from the office and I'm home, then I shut myself out from the office. Unless, of course, there is an extreme emergency.
Mhm.
But uh, every time I get a call, so-called emergency, I evaluate to see if it really is an emergency, because it's all about perceiving something and perceiving
Mhm.
its emergency. So I shut myself out, and then I focus only on the hobbies that I have. And when I'm focusing the hobbies, when I'm working on my hobbies, I focus only on that.
Hmm.
There's nothing that will distract me. In fact, it's almost like my second profession at that time.
Hmm. Okay. Yeah, in fact, this reminds me. Recently, I was listening to a podcast where the founder of this clothing company called Patagonia was talking about how he's able to afford vacations. Apparently, he takes off a few months every year, saying, "I want to be in the outdoors." And someone asks, when someone calls me, I say, "Oh, if the warehouse burnt down, you know what to do. Let me enjoy my vacation." Yeah, that's good. So thanks, Paul. It's been really an interesting conversation. I'm sure there are a lot of tips. One may have to listen to this twice or thrice, to actually glean some of the techniques that you've been following and the discipline that you've been able to consistently have for the last so many years.
Thank you, Shiv, and thanks for the opportunity to share my story so that others can also gain from it. In fact, I've been wanting to share some of these stories, and I didn't find a forum, but this was good.
Yeah, you're welcome. If
Thank
you
you.
have more stories, yeah, I'm sure our listeners would like to listen to those
Sure.
as well.
Thank you.
Thanks, Paul. If you like the show and would like to share your experiences with the community or know someone else who might want to do that, please get in touch with us at podcasts@ pm-powerconsulting.com. That is podcasts@ pm-powerconsulting.com.
Please rate the show on Podchaser, Stitcher, iTunes, or any other podcast client that you find us on. Please also share our episodes with your friends and others in your network. If you or anyone you know would like to be featured on our show, do write to us at this email address: podcasts@pm-powerconsulting.com.